Edit?
I think your slides, slide 11.
Slide 11?
It's replacing a cell with
This one?
your slides.
My slides. This one?
Yes, 11. Replace a cell with wood.
Assert with?
Remove a cell.
Remove assert.
Yes, and write wood.
With.
Yes.
Okay. Thank you so much. Okay. Yeah, I didn't know this. Okay. How do I handle this?
I don't know, I just tried it.
あれもう映ってるかも。Okay, YouTube is on live. Yeah, I guess this is a bit, video mistaken, I guess. But yeah, okay, let's start. Okay, this event is TC39 and JSConf.jp collaboration event. So I would like to gather a lot of opinions and some problems and with these people. Yeah. So the first of all, we would like to show the event explanation. Sorry. Okay, here is the event page. And so this event says TC39 ECMAScript and JavaScript, JSConf.jp will hold a collaboration meetup. We would like to talk about JS future pain points, how TC39 runs our specs, etc. So no, this event is not JSConf.jp November event. So yes, this is not. This is just not. And the schedule is, so TC39 work introduction by Little Dan from 7 to 7:20. And next, so Spider Monkey bite-sized architectures by Daniel Miner is good. Okay, so 7:20 from 7:20 to 7:40, and we would like to take a break at 10 for 10 minutes, and after that, we would like to discuss about the future weak points, stuff like that, and later, so we would like to solve pizza or sushi time and stuff like that, and so free discussion time is on 9 through 9:30, stuff like that. Okay, is that okay? Okay, so approach please. Thank you. Okay, so the first talk is TC39 works. Okay, wait a moment. Okay.
Is it sharing on the remote?
Yeah, currently it's screen is shared online.
Oh no. That is
Yeah, so you.
sorry.
No, no problem. Okay.
Hello.
Let's start.
Thank you everyone for having me here. So thank you, Yosuke, for hosting this event and organizing. We're having a TC39 meeting here in Japan, right on the other side of Tokyo Station, and so we wanted to meet the Japanese JavaScript community, and I'm very happy that Yosuke has organized this so we could get together. So, how TC39 works. I want to talk about the TC39 process. TC39 is a technical committee of ECMA. So I'll tell you what ECMA is. ECMA is an open organization, and we would like to have more participation from more members. There are very few Japanese companies involved in ECMA now. I'm glad that Sony Interactive is. So then any discussion. So the ECMAScript Standards Committee, TC39. We work on a number of standards. ECMA 262, the JavaScript specification, ECMAScript specification. We also have Intel, ECMA 402. So this is used for formatting dates and numbers, and later even for templating messages with Intel message format. This is another standard published by us. We have a security task group, and now we're even working on a new standard for source maps. Source maps are a tool for debugging JavaScript, which has been unstandardized. And now we're trying to add it to a new standard. So TC39 works on the JavaScript specification, just a big HTML document that describes exactly how JavaScript works. And it's developed in GitHub. We make pull requests, there's issues. You can see there's a lot of issues in pull requests. We meet every 2 months for 3 days. The agenda is posted online. We make PRs to it. It's just on GitHub. Sometimes we meet in person, but hybrid, of course, sometimes remote. And we review proposals. So the proposals advance through stages. At stage 1, a proposal is just an idea. Stage 1 does not mean that the committee has especially bought into the idea. It just means we're talking about it as a committee. Stage 2 means that there's a first draft of the proposal that has some details written out, and we agree as a committee that if possible, we want this to eventually become part of JavaScript. Stage 3 means that all the details are worked out as much as we can, at least at the design phase, and it's ready to start implementing the proposal if it hasn't already been implemented. So it's almost like a final draft. And at stage 4, a proposal enters the standard. It enters the standard once there are 2 implementations, so 2 different web browsers or other JavaScript engines, and it has to also have tests. There are tests, just like you write tests for your application, that run against JavaScript engines, and those are required. Oh, multiple implementations. So those tests, for web standards, there's something called web platform tests. We also write those, but our tests are in a repository called test262. These are required for stage 4. The great thing is that all JavaScript engines these days have continuous integration, CI, which runs the test262 tests. So we're working on expanding this test suite constantly by adding tests, but also making the structure easier to add to. So just developed in PRs in GitHub, like everything else. These are some tests for BigInt. We've been working on a lot of proposals in TC39, and I like the list of proposals that Yosuke gathered from this community earlier, but I wanted to raise attention to a few of them. So first, some things that we've done in TC39 over the past few years. We've added weakref and finalization registry. So now it's possible to point to a JavaScript object, but if it becomes garbage collected, then the pointer becomes null. You can also get a callback with finalization registry. Top level await in modules. It's possible now to make a JavaScript module, which when initializing, it needs to await some condition, some promise. Question mark dot, optional chaining, and question mark, nullish coalescing. These make it easier to deal with values that may or may not be there. So with question mark dot, if you have a value that might be null or undefined, then it will just return undefined rather than throwing an error. We've added private fields. starting with a hash sign, a field, or property, or method in a JavaScript class can be private and only accessible within the class. And with internationalization, we've added more features. In stage 3 proposals, these are things that, so the recent major standards, these are already implemented in multiple browsers. You can use them. They're there. They're done. They're standard. These stage 3 proposals are almost standard. They still might change a little bit, but we think as a committee that we've already designed them as much as we can, and we think that they're going to be implemented in roughly this way. One of these is temporal. I was very happy to see that that the community here voted temporal the most interesting proposal. Temporal adds new date and time types to JavaScript, so you don't have to use moment, and you get better accuracy. Just want to jump to stage 2 proposals. We're working on some more advanced things. One is async context. Async context lets you have basically thread local variables in JavaScript. So Zhengdong here in the audience is campaigning async context. And this is useful because it gives you something like Node.js's async local storage, but it can be used in the web. So for example, Zhengdong is maintaining the OpenTelemetry bindings for JavaScript. And to do that, OpenTelemetry needs to pass a span ID around, and that normally is in a thread local variable. But in JavaScript, we can't do that. Anyway, async context solves this problem. Record and tuple are some immutable value-based objects in JavaScript. These, we wanted these to, the people who were proposing record and tuple, who I was working closely with, wanted this proposal to be at stage 3, but it received some criticism that it wasn't yet ready. So sometimes things are at stage 2 because they're on their way, they just need more time. And sometimes things are at stage 2 because we don't get consensus to move forward with them. Everything that TC39 does is by consensus. The whole committee agrees that we want to move forward with ideas. And this is conservative. It's good to be conservative because then we don't make as many mistakes. So record and tuple, although I wish it could happen, it's good. It's also good to avoid potential mistakes. Deferring module evaluation. This is a proposal that Nicolo here in the room has been championing. This makes it faster to start up an application because it defers when the module evaluates. It turns out evaluating modules takes a large percentage of startup time. Oh, am I gonna run out of time?
I ordered sushi.
So a new effort that we have is source maps. Source maps are a format that holds metadata related to compiled JavaScript code. You know, when you write applications, you run TypeScript, you run Cursor before shipping code to production, but that means that the code that you're debugging is different from the code where you developed. Source maps map between these two, but source maps do not have a clear standard. Source maps have been described in a Google Doc, which is kind of vague, kind of incomplete, and there's no conformance tests. When you implement source maps, you have to figure out yourself if the tests are good enough, and they often aren't. So we made a new task group of TC39 called TG4, which is investigating how to create a source map standard. We've already iterated on the previous version, And we're working on becoming more specific, writing good tests, and adding features such as mapping variable names. So if you're interested in source maps, please let me know. I would love to work with you in TC39 TG4. So let's talk about ECMA. What is ECMA International? Who are they? Well, we're an organization which develops standards in the area of computing. It has a very general scope. Some of these are about programming languages. Some are about like CDs and DVDs. Formats were originally defined in ECMA. ASCII at some point was standardized in ECMA and extensions of it. Anyway, it has a proven track record with many different publications. And something that's very important for TC39 is that ECMA has the ability to publish standards that are freely available. So we can make sure that all the patents and copyrights are licensed to all of you developers for free and unlimited use. So we're working on this broad scope, including hardware, software, consumer electronics, many programming languages. As I said, I want to emphasize that ECMA is an organization that you can join. Any organization can apply to join ECMA. For companies, that's based on paying a membership fee. For universities and nonprofits, ECMA encourages free participation. So please email the ECMA Secretary General, Samina Hussein, who's right here. Came all the way to Tokyo to see all of you and participate in TC39. So please email Samina to get started. It's easier to do if you're in contact with the Secretariat than if you just try to do everything yourself. There's also a possibility to attend TC39 meetings as a trial if you're considering membership. And contributing to TC39 requires signing a license agreement that anything that you contribute to TC39 is licensed to ECMA to share with everybody. Even without joining ECMA, we encourage you all to participate in TC39's work via GitHub. In fact, most of our work, as I showed before, is on GitHub. At the meetings, we review things and make decisions, but you can really follow everything very well on GitHub. And there's an invited expert program to participate as a non-member in certain cases in meetings. So thank you, everybody. Does anybody have questions?
Questions? No?
Yes.
So how many people are there in total in TC39?
Well, it's hard to count.
Really?
At this meeting, there's about 25 people who signed up to attend in person in Tokyo. I imagine we'll have a similar number calling in online. Overall, there are over 200 people who have kind of signed up as delegates, but they don't always come to every meeting. Maybe there's around 100 people who are more or less active. In addition to other people who are active online but not members.
So how about this company? This company has 1,500 people. In this case, so the company pays a membership fee based on size.
Yeah.
Based on size means that is employee counts or.
Details
are on the ECMA website. Yeah.
I think a good comment. So if you're a large organization and you want to have voting rights, then you're an ordinary member, and there's a certain people that. If you only want to participate in the community not have voting rights, then you may join for contract fee, and the fees are on the website.
Okay.
If you're a small organization, meaning lesser employees or lesser revenue, then you give a smaller fee, much smaller fee, and then it's free for the non-profits as well.
Okay, I got it.
Yeah, there's like 5-6 different fee classes.
Yeah.
So 5. Okay. Thank you.
It must be fine. Okay.
Yeah. Any other questions?
Any other questions?
I'm just curious that what kind of hardware is ECMA working on? You say.
So, this opticals, what kind of hardware is ECMA working on? ECMA has historically done a lot of work in optical storage technologies, and I believe there's still active work in this area. There's also work in JavaScript in embedded systems. So this isn't hardware as such, but it's libraries for interfacing with hardware, low-level libraries that are exposed via JavaScript modules for use in embedded systems. So maybe other people here know more about it.
Maybe I can also just comment.
Yeah.
We also have a standard on BMI that's sort of mentioned in interface. Thank you. I thought you could hear my voice. We also have standards that work on the interference side. That's currently under work. There's also a community that works on fan noise, something very basic. So ECMA stands for European Computer Manufacturers Association. That's historic, but there are a lot of standards on the hardware side. If you go to our website, you can have a very clear picture, but we can talk offline also. Okay.
So no one has question. Okay. Okay.
Thank you.
Thank you so much. Thank you again. Okay. I need to get you ready.
Is it question?
Oh, yeah. There is some questions on this chat, but it's very hard. Okay. Is there a specific reason why 39 is chosen instead of 38?
So ECMA numbers its technical committee. TC stands for technical committee sequentially. TC39 is the 39th technical committee that was founded in ECMA. Now ECMA has, TCs all the way up to 53, but some of those TCs became inactive and closed. So it's not that we have all of those, but anyway, TC is the 39th. TC39 is the 39th technical.
What is TG?
Technical committee,
TC is technical committee, and
Technical
TG
committee.
is task group.
task
So
group.
TG is like a subgroup formed for a particular purpose within a technical community. We have TG2, which is for internationalization, and now TG4 for source maps.
Mhm.
TG1, it refers to TC39 itself. The reason is because when royalty-free patents were initially
TC39 is just
established by
technical
ECMA,
committee
the
number
policy
39.
was you only make a single task group be royalty-free. So we had to move all the work into a task group. Now, all of TC39 is royalty-free because ECMA changed its policy to allow royalty-free task technical committees. But we still do our work in TC39 TG1.
He asked the question.
TC39 is most active group in ECMA standard. Oh, okay, I got it. Okay. So the next talk is Spider Monkey bite-sized architecture. So thank you for coming.
Thank you. Hi, so my name is Daniel. I'm part of the SpiderMonkey team at Mozilla. And tonight I'm going to talk about SpiderMonkey bite-sized architectures. But first, what is a SpiderMonkey? Well, it's a member of genus Ateles. It's considered the most intelligent New World monkey, and although they lack thumbs, they make up for it by having very long limbs and tails. And what then is SpiderMonkey? Well, it's a JavaScript engine inside of Firefox. Engine's a part of the browser which executes JavaScript code. So an engine consists of parsers, interpreters, just-in-time compilers, garbage collection, and a library of useful functions. And that's what I'd like to talk about tonight. So here is a simplified architecture diagram for SpiderMonkey. So this is going to serve as the roadmap for the talk tonight. Simplified in that it's kind of my understanding of the system. It doesn't get into all the details that say, an expert in garbage collection would know. So I'm going to start with the front end. So what's the front end? So it's something that takes JavaScript source provided by the host environment. And the host environment can be a browser, can be a standalone JavaScript shell, can be JavaScript embedded in another application like a send node, and it's going to transform it into a format that's usable by the rest of the engine. So the first step of that is the tokenizer. So a token is an indivisible unit of input to the parser. And so a tokenizer is going to divide input source, like this function here, into a list of tokens. And once that's done, then the parser can use that list of tokens and the grammar for JavaScript and use it to construct what's called an abstract syntax tree. And so talking about parsers in SpiderMonkey, we have at least 4 different parsers. So we have a syntax parser, which is going to run quickly, attempt to avoid allocating memory where possible, but it only checks for syntax errors. So the idea here is if there's a syntax error, we can fail quickly. There's no errors, and we move along, and we run what's called a full parser. So that's going to run more slowly, allocates memory, but it actually builds the abstract syntax tree. And that's only 2. There's actually another dimension here, which is that we have versions for UTF-8 and UTF-16 input, which gives a total of 4 parsers. Next thing to talk about are virtual machines and bytecode. So a virtual machine is an abstract definition of a computer. It's usually defined at a higher level, the instruction set of an actual CPU. And bytecodes are the instructions that are understood by the virtual machine. So if we look at this little function I've been using all along, this is the bytecode that SpiderMonkey would generate for it. So here's the process of bytecode generation. So we have the input, which is the abstract syntax tree. We have the output, which is the bytecode. And basically what happens during generation is we walk through each node in the syntax tree and generate bytecode that corresponds to it. And then that's passed along to the consumer, which is the interpreter, but also the just-in-time compilers. So moving on, let's talk about interpreters. So what's an interpreter? It's a program which executes the instructions for another program. There's different ways of implementing this. One way is just by walking the abstract syntax tree and evaluating each node. So this can be done. It's simpler to implement, it's slower, but it was actually how early versions of Ruby were implemented. And the other alternative, which is what's done in SpiderMonkey, is to basically implement the virtual machine itself. So in this case, the interpreter is running in a loop, executes each bytecode one by one. It's basically just a giant case statement or switch statement or go-to statement, where each label corresponds to bytecode. And this ends up being much faster than walking the abstract syntax tree directly. So first interpreter, there's multiple interpreters inside SpiderMonkey. So simplest one is what's called a C++ interpreter. It's implemented as a giant go-to statement inside a loop, like I just talked about, where each label corresponds to bytecode. So here is the implementation of the getarg instruction in C++. The other interpreter is what's called a baseline interpreter. It runs very similarly to the C++ interpreter, but it also collects type information and other metadata as it runs. So if we look at the same function again, we can guess that most likely the parameter x is going to be a number, most likely an integer. So is that some information that we can make use of? And the answer is yes, and brings me to just-in-time compilers. So a just-in-time compiler uses data that's been gathered while interpreting code to choose what to compile. So we know from experience that most JavaScript code is only going to be executed once. So what we want to do is make a trade-off between the amount of time it takes to compile some code and then execute it versus the time it takes just to interpret it directly. And inside of SpiderMonkey, we basically have sort of 3 levels of this. So the baseline interpreter has no compile time at all, but the code, or the interpreter itself, is relatively slow. Then we have what's called the baseline compiler, which has a faster compile time, but generated code is not going to be optimized. Then we have Ion, which is our optimizing compiler. So that has the slowest compile time, but it's generating optimized code. So here is a C++ representation of JavaScript scripts inside of SpiderMonkey. So we have a base script, which is just metadata about the script itself. We have immutable script data, which is the bytecode, like I've already talked about. We have JIT script, which provides inline caches, which I'll talk about next. That's used by the baseline interpreter. And then we have 2 levels for compiled native code, baseline, which isn't optimized, and Ion, which is optimized. So moving on to inline caches, first thing to understand is what's a dynamic dispatch in this context, and that's when we make a branch based upon type information. So if we have a function, and the parameter can be a string or an integer, we have to decide which code to run based upon the type of that input. And so inside SpiderMonkey, we have what are called inline caches, which store the results of previous dynamic dispatches. So this avoids the cost of branching, and it means the code can be specialized for a particular type. And it's called inline because it's stored inline with the function itself to avoid the cost of non-local memory accesses. And so what this does, along with being faster, is it also gives us some metadata. So that helps us store the information on the types that have been passed in. And it also lets us know which parts of the function are actually being used. In this case, if there's no inline cache, we know that that particular chunk of code has not actually been executed. So baseline interpreter, basic idea is to replace bytecodes with what are called stubs in the inline caches. So for this particular function, say it's run in a loop and it runs often enough, say 10 or 12 times, what will happen is the baseline interpreter will create stubs in the inline cache for it. That will depend on the type that's been passed in the parameter. So in this case, if it's always being passed an integer, we'll end up generating stubs for integer 32 multiply and integer 32 addition. And although it seems simple, this actually gives the considerable speed ups. So executing this code in the future might be something like 6 times faster than in the simple C++ interpreter. And this intermediate data that's being generated is called cache IR, which will be used in other parts of the system later on. Moving on, so the first level of compilation is done by what's called a baseline compiler. And basically what it's going to do is avoid this big dispatch loop for each individual bytecode by just going through and generating bytecode or generating native code for each bytecode in the script. So this avoids a lot of overhead with jumps and loops. It's still using inline caches like the baseline interpreter, but it's optimized away some of the other problems that we had. And so this will be maybe twice as fast as a baseline interpreter, so we're up to about 12 times faster than C++ interpreter at this point. And so that brings us to Ion, which is our optimizing compiler. So it starts with a bytecode and the cache IR, and it runs through a component that's called a work builder. And what that is going to do is generate an intermediate representation that's called mirror. And this intermediate representation is a graph structure, and it's set up to be suitable for optimizing. So the next stage, the optimizer runs. I can't remember exactly how many optimization stages there are, but I think something 15 or possibly 20, and that's going to generate a lower level intermediate representation that's called Lear. And when that's ready, we have a register allocator that's going to go back over to Lear and try to find a good set of CPU registers to assign. And after that has been done, we can actually run the codes generator and generate our optimized native code. And so this stage is somewhere between 3.5 and 4 times faster than the baseline compiler's code, which putting it all together gives us like 45 times faster than the C++ interpreter. But sometimes things can go wrong. So we have what are called bailouts. And this happens when our assumptions about the input types are wrong. So we all know JavaScript is a flexible language. So though most people would probably call this code with integers or floating point numbers, it's completely valid to pass in strings, booleans, and we need to be able to support all of these things. So if we hit something like a string, that basically forces us to drop out of our optimized code and go back to the baseline interpreter. So what we can do at that point is attach a new stub in the inline cache to handle different types, so that's completely fine, but it means we're no longer running our optimized code. And if this happens often enough, we might end up just tossing away the optimized code just because we're not going to use it. And speaking of tossing things away, we move on to garbage collection. So what's a garbage collector? Basically, it manages allocating a frame memory automatically. It maintains a graph of objects. Inside SpiderMonkey, things that we know for sure are live are called the roots. So they end up being the roots of the graph. And we run a mark and sweep algorithm. So we start at all the roots, we mark anything we can reach from a root as live. And then we know it's safe to get rid of anything that hasn't been marked. So Through this algorithm, we don't have to worry about cycles between objects, which are all dead. We don't have to worry about completely isolated objects that will all be caught. The garbage collector inside a SpiderMonkey is a generational garbage collector. So what this means is if you have a newly allocated object, it's going to live in what's called the nursery, along with all the other newly allocated objects. Unfortunately, it's a sad fact of life that newly allocated objects in JavaScript don't live very long. So periodically, we run what's called a minor garbage collection. And as a result of that, some objects are just going to go away. They're not in use, and they'll be collected. Objects that are still in use are moved to a different chunk of memory, which is called the tenure key. So we know that anything that survives a minor garbage collection is likely to stay around for a long time. So it's moved to a separate section of memory. But we still need to collect those. So that's called a major garbage collection. And similar to the minor garbage collection, some objects are no longer going to be alive after that. But the ones that make it, this is also an opportunity for us to do what's called compaction. This means we can move objects around in memory so we can have better locality of access, or we can free unused chunks. Another thing we have to worry about is cycle collection. So this is important, I think, particularly in the browser, but any place where JavaScript's embedded inside of C++ is probably relevant. So an example of this would be a cycle between the host environment and JavaScript. So if we have a C++ DOM object that's holding a JavaScript callback, and that JavaScript callback holds a reference to a DOM object, the garbage collector inside a SpiderMonkey can't see these cycles. So this requires careful coordination between the cycle collection, between cycle collection inside a DOM and a garbage collector. So inside a DOM, we use reference counting, and there's a cycle collector that goes through to tries to find cycles of things that only refer to each other, and that needs to cooperate closely with the garbage collector inside a SpiderMonkey. Okay, moving on to the last chunk of the engine that I want to talk about tonight, built-ins. So what are built-ins? They provide the kind of standard library sort of functionality. So things like math.round, string.search, regular expressions, internationalization, all these sorts of things. Inside a SpiderMonkey, they're implemented in a mix of what we call self-hosted JavaScript and C++. So we use JavaScript where we can, and C++ when necessary. So sometimes that means performance, although sometimes it can actually be faster running compiled JavaScript than switching to C++ all the time. And sometimes we do this because we want to be able to use third-party libraries that are implemented in C++, like ICU for C, which is the internationalization library that we make use of. And the other thing to know is that self-hosted JavaScript is a subset of JavaScript. So we're trying to restrict what we allow in self-hosted code to avoid security problems. We have an example here, internationalization. So if I know Nicolo-san would be in the room, I would have chosen segmentation instead. But here's an example of Intel.number format, formatting numbers for different types of currencies. So what this looks like inside the engine is we have self-hosted code, which is providing the API that's being exposed to JavaScript. We have C++ code, so that's implementing the underlying objects like Intel.number format, and it's also handling integration with internationalization libraries. So we mostly use ICU for C inside of Firefox. It's a very standard choice. I'm pretty sure it's used by all the browsers and all operating systems. And CLDR is the data repository, that's the underlying data that's used for the algorithms in ICU for C that are provided for each language and locale that we support. The other example I'd like to give is for regular expressions. So it's actually a very similar story. So self-hosted code provides the API that's exposed to JavaScript. We have C++ code that's handling integration with the underlying regular expression library. The library we use is IRregex. That's actually the same library used by V8. It was originally written by Google for V8. So here the integration is a little bit more challenging. So we have a layer which pretends to be enough V8 that we can run it inside a SpiderMonkey. And the other thing I find fascinating about this is that IRregex is like a miniature version of the JavaScript engine as a whole. It has its own parser, its own bytecode, its own interpreter, and its own just-in-time compiler. So that puts us up to, I think, 5 parsers, 3 interpreters, and 3 just-in-time compilers, if I'm counting correctly. So here I'd just like to say that if you have any interest in how TC39 proposals are implemented or how interpreters work, a lot of TC39 proposals can be implemented in JavaScript inside SpiderMonkey just using self-hosted code. You don't have to be an expert to do this. If you want to learn more about how interpreters work, I think this book, which as far as I know is only available in English, it's called Crafting Interpreters. I think it's excellent. It goes into more detail about everything I've talked about tonight, except for just-in-time compilation. And if you want to contact us, this is our Matrix channel. And this bug in Mozilla has all of the proposals that are currently at stage 3 in TC39. So you can search through there and see if there's any that haven't been implemented inside of SpiderMonkey yet. And we'd be happy to have your help and happy to help out if you'd like to contribute. So the other thing I wanted to talk to you about tonight is bite-sized architectures. So I like this cover from The New Yorker. It's making the point that we all have our own point of view in the world. So people that live on 9th Avenue in New York City know a lot about 9th Avenue in greater detail. They probably don't know as much about Japan. So this is where we are. I don't think that's a bad thing, though. What that really means is that everyone has something to teach us. Everyone has their own point of view in the world, something that they know in more detail than someone else. And so, yeah. So how does that apply to software? Well, I think it's the same story for a sufficiently complicated system. Everyone in the team is going to know the parts that they work on directly better than other people. And for a really complicated system, it's not really possible for everyone to understand the whole thing anyways, or at least not in any detail. So how can we build this understanding? What we've been doing on the SpiderMonkey team is something called bite-sized architectures. So this works by the whole team getting together for about an hour or so. And the first 5 minutes, we get out pen and paper, and everyone draws their own picture of what they think the architecture looks like. And then we take turns sharing our drawings, having conversations, discussing them. And I'd like to say it's not our idea. It comes from a person named Andrea Magnorski. I have some links there to her blog and a website that she's put together. Her version has a bit more process than what we've been doing, but it's more or less the same idea. So here's a collection of some of our drawings from one of our sessions. So I think these are all quite nice. You can see there's quite a bit of variation in level of detail. Some people go into a lot more detail about one part of the system. So there's one here where someone's done a lot of time on garbage collection. Some of them are quite simple. Some people took a more procedural approach where they traced the script's motion through different parts of the system rather than kind of looking at the architecture. But I think there's something to learn from each one of these. So what were the benefits for us? Well, just the quiet time together as a team, working on something together was really nice. Our team is completely remote. So having these sorts of things is quite important for us. The drawings themselves are very useful. So I think you can tell I use these to help prepare for my presentation. Especially useful to help understand parts of the system that I wasn't that familiar with. But I think the most important thing for us was just the questions and the conversations that resulted. And that to me leads to the idea of psychological safety in teams. So when you have psychological safety, it means that people in the team feel safe to raise ideas, to voice opinions, ask questions, and make mistakes without having negative consequences. I think bite-sized architectures can be a great way to build psychological safety in a team because it forces us to admit when we don't know something, and it makes sure that we're asking questions. That's it for me. Arigato gozaimashita. Thank you very much. I don't know if there's questions or.
Yeah, question. Check online. Check online.
Oh,
Okay.
yes.
No question.
Oh, perfect. Oh,
Okay.
Okay, Nico.
Does Irrigate happen to have a garbage collector too?
I don't know, but it actually, yes, let me answer that. Inside SpiderMonkey, it's hooked into the overall garbage collector. So I don't know what the story is in V8, but I assume they're doing the same thing. So in some ways, that's why my architecture diagram was simplified, because the garbage collector basically just connects to every single thing in the system. which makes it actually one of the most important parts of the engine, especially when performance is concerned.
So during the optimization, you mentioned that if a function receives an unexpected type, it goes out of the optimization. So I was wondering if to like TypeScript that can enforce a certain type correctness can be measured as an improvement in the performance, or if they're not at that level, it doesn't have any impact with types.
Thank you. That's a good question. So the answer is we don't have that information by the time it's actually running inside the engine. And so because of that, we have to be prepared for any type to come along. So hopefully people will be consistent and they'll continue calling with the same type they've been calling along, which I think is usually the case. But yeah, sometimes yes, we just hit something random and we're stuck falling back to the baseline interpreter.
Maybe to expand on this question a little bit, one of the things that TypeScript provides is that it sort of ensures that you don't call a function with more than one different type. For example, you call it the string only or only the number. And like, my question is like, does this help Firefox increase performance for the JavaScript that you write with TypeScript?
Yes, and in that case, yes, because you wouldn't hit the bailout condition, which means that we could continue running the optimized code. So yes, in that case, it would help. It's just not information that we have directly available in the engine.
I've heard some people say that TypeScript is unsound. What does that mean, and how does that relate to this whole discussion that we've been having already?
I asked the same question to him. And he answered
in particular, that's why I need this possible type, because that's sound. That's like
Nice question, thank you. I don't feel like I'm on the spot at all. Soundness, what does soundness mean? I can't remember. So that means it's not,
It doesn't enforce the type.
yeah. I don't know. No, you didn't phrase, you phrased it just fine. I don't know. Does anyone else know?
So TypeScript is not sound means that it can be wrong. Like it doesn't actually guarantee that your program is correct. It just tries to help you make it correct. So you cannot really rely on TypeScript types to optimize because sometimes they'll not go the way the types expect.
So this is a important thing to highlight is that people, like Dan was saying, are different perspectives on different parts of the system. And something that happens a lot is that the people who are working on JavaScript engines are C++ experts mostly, and like experts in the details of compilers and engines and that sort of thing. And like I am mostly an expert in the ECMAScript specification, and that means like the set of things I know is very detailed about like the way the specification is written. And I write some JavaScript, but I don't like write all JavaScript all the time. So the things that come up as a JavaScript programmer are very different from the things that come up like when you are working on any other part of the system, which is why we want to encourage participation from more people in general in TC39, because bringing more perspectives really is very valuable. We really need to have the people who are working on the engines, and we also really need to have the people who are writing JavaScript all the time, because we just don't think about the same things at all. This is my comment. Thank you.
This is a very related question, but do you think it will be useful to use TypeScript type information, even though it might be wrong? Do you think it can be useful as a kind of hint, as an optimistic way?
So yes, 99% of my job is writing C++, but I will try to answer your question. So anything that can check your program, including TypeScript, even if it's not right all the time, the more it makes your resulting JavaScript consistent, the better chance that the engine will have to optimize it.
Anybody has some questions?
Is it more questions about TypeScript?
Yeah, I have one thing to add to this. Like, usually the types that are used by the engine are much different than the types that you would expose in TypeScript. Like, for example, just inside of, I know this specifically for V8, like V8 has 5 or 6 different string implementations, and like it has floating point numbers and integer numbers, and like different size integers for small integers and large integers. TypeScript just has a number. Like, TypeScript just knows what number. So while sometimes this may be able to help, most often the engine needs much more specific type information than what TypeScript can provide.
A simpler reason why the types in TypeScript cannot be used as hints is because the most basic optimization that an engine does is that most of the code is interpreted. Most JavaScript code that gets sent to an application is run 0 or 1 times. So it doesn't make sense to compile. Once you compile code only after it ran multiple times. So you've already been able to observe what types run through the program. For that reason, the type hints are unlikely to be very useful.
I'm going to take a pivot from TypeScript and ask about engine details. So I think Bun is a relatively new engine recently, and it was written in Zig. And from the benchmark, so its performance much better than either Node or Dino, which use a variant of V8. So what is your opinion on Bun and using Zig instead of C++?
You work on Dino, right?
Yeah.
No, Luca. There you go.
Disclaimer: I work on Dino, so I may be biased. I think it's interesting. It's interesting to note. What's also to note is like specifically the JavaScript engine that Bun uses is the WebKit JavaScript engine, so the same JavaScript engine that Safari uses. So while there's some performance improvements that it gains through that, you can usually say that all 3 of the major JavaScript engines are about the same speed at executing any bit of JavaScript you give it. Like in some cases, one engine is faster, and in some cases the other is faster. I think specifically what makes Bun faster in many cases is that it deals with I/O, so with input and output from the program differently. And maybe Zig helps there. And I guess we'll see that over the next couple of years as it evolves. And a more unbiased opinion.
So when you see engines like Node.js, Cloudflare Workers, Bun, they're not actual JavaScript engines. They use other JavaScript engines inside of them. They use V8 or SpiderMonkey, which is what Bun uses, or JavaScript Core, which is what SpiderMonkey is what Dan Miner works on. Anyway, those 3 engines, or possibly others, they embed those engines. The same way as a web browser embeds a JavaScript engine, Node and similar systems embed an engine, typically without real modifications, unless they're kind of new and getting their act together. In general, all 3 of those engines are written in C++. Zig or Rust in the case of Dino is just a thin wrapper around that. So the choice of language, therefore, doesn't affect the performance very much, unless it changes the I/O.
Performance of the JavaScript. It may affect the performance of console.log or fetch.
Yeah, it doesn't affect the performance of the JavaScript code that runs inside.
I saw in the previous slides, SpiderMonkey has 2 parts of the first one checks the syntax errors, but I wonder why, because in the most of cases, JavaScript code are bad?
So I don't know why that particular decision was made, and if it still makes sense from a performance point of view. I imagine it does, but the idea is just to be able to fail quickly if there is a problem. And so that particular parser does almost nothing. So it goes, it has the, it takes the time to parse, but it's not actually building any structures in memory or doing anything like that. So it is much faster than the full parser. But yes, that's an interesting question. If most things are being checked before it gets, well, that's not even necessarily fair because there's tons of old websites out there. So who knows? But, yeah. Ross?
So I think this actually is expectable to be in each engine because it kind of corresponds to the concept of early error in the spec.
Yeah.
And there used to be, I think I once rectified this situation with a normative PR, but like there used to be multiple types of early errors and we just called them all syntax error in the end because it was less confusing that way. But basically, I think one case you could think of is just like a function that's around but is never executed. I think would be an example of a case where like there might be some kind of reason for even its existence to have the script error out because just obviously that is syntactically invalid as a script. But there might be other issues that only crop up upon actually trying to use that function. I'm sure there's room to add many things here.
So in some programming languages, like in Bash or HTML or CSS, you can have a syntax error, but the rest of the program keeps running. And just if you run that code with the syntax error, then it might have an error or skip itself. In JavaScript, it's different. If any of your program has a syntax error, that your program needs to error out before any of it runs. So like was being said, if you have a function that maybe you never call, you don't really want to generate all the bytecode for it because that takes too much time. You just want to check whether it has an error and then throw it away. Sometimes it's hard to determine in an engine whether or not it should be thrown away or not, and that's yeah.
And I have one more thing to add to this. I don't know how it is for SpiderMonkey, but V8, for example, also has this pre-parser, and it uses this information when it scans, when it parses modules, for example, and can find all the module specifiers very early on, so it can start fetching them before it's done the whole AST parse, which can help speed up things. Anybody else?
I would like to ask a question about that. So currently, SpiderMonkey has 3 stages or 4 stages?
Oh, for the JIT, 3.
3 stages.
Yeah.
Okay. The end will be having 4 stages, is that right? And,
yes.
So JavaScript core also has 4 TLJ, so 4 stages, is that right? And it's like a car gear. So yes. So the first gear is not so fast as the maximum speed, but it is really fast to move it yeah, from 0 to 1, and so that is really fast. And so SpiderMonkey only has 3 stages. So is that okay? So other agent has 4 stages. So do you have any plan to have more stages about this agent?
Thank you. Good question. Yeah, so that is something that we were talking about the last time we had a work group and work week and got together. So it's a tuning thing. So like the amount of optimization you do at any one stage can be controlled. So right now we sort of have like no optimization and full optimization, but there is definitely a way of just only applying half the optimization stages. But it's just like it becomes like a performance tuning question then, whether doing half of the optimizations is that much faster than doing all of the optimizations, and what's the quality of the generated code. So yeah, we are aware that I wasn't aware of JavaScript core, but we are aware that like V8 has an extra level compared to us, and that's something that we're interested in investigating.
Okay. And
Just a response to that, like the fact that JavaScript core has 4 levels is sort of something that's just arisen naturally. It wasn't like there was a goal for there to be 4. There's been talks over the years of eliminating stages or adding as much as 3 more. It's mainly just a trade-off of how much work and optimization can be done versus how much extra memory and time is required to do that. It has nothing to do with like, oh, the target is 4 stages or something. It's just, that's a number that over the years has been sort of settled upon us. This is something that we've noticed in the various stages we've seen has been a good trade-off. Let's see if, maybe we pull out a particular optimization and make it its own stage that is in between stages 2 and 3, let's say, and see how that goes. And sometimes it works, sometimes it doesn't. I mean, at one point, JavaScript core had 1 stage, then 2, then 3, then 4. It's just arisen naturally. It's not like the number of stages has anything to do with some result. It's just, that's how they found things to be efficient, how they found things to be performant. It's just, the way that things are.
okay. So in that case, so JSC will need more stages, or it's not just stage, it's just a feature.
They could. I mean, I know that there's been times where they've talked about adding new stages, experimenting, but it's not, sometimes those experiments work, sometimes they don't see an improvement.
Right.
And so it really is just some amount of this is guesswork, because at the same time as, predictive as JavaScript is, certain parts of the JIT are profiled. And so they don't want to obviously instrument on every single action that occurs. You want to pick some portion of that. Sometimes you get lucky with the portions you pick that it gives you hints enough to do something faster or better. Sometimes the portions you pick don't really give you any information.
Okay.
So as sort of declarative and not declarative, but consistent as a JavaScript engine may be, there still is quite a bit of variability to it. And that can influence how many tiers you have, let's say, as to the kinds of guesses you make, how consistent those things are to actually provide you with a benefit for the things you're looking for.
Okay, I got it. Yeah, thank you. Any other questions?
I was wondering if you could provide any insight or commentary on the mechanism by which already compiled code would be affected by dynamic after-the-fact manipulation of built-ins.
No? I'm sorry, no, I can't answer that question. But, if someone else in the room wants to.
Well, Kevin's going to say what I would have said.
So I can't speak for other engines, but at least within JavaScript core, almost all of the built-ins are designed such that things that exist in userland, like from a developer, cannot affect built-ins because they don't want to avoid these kinds of problems. Only the places where the spec specifically allows for things to be overwritten from, certain like symbol decorator or something like that. That's where built-in code can actually be affected. Other than that, they try to use like sort of the actual underlying code that is exposed to JavaScript rather than using the direct JavaScript version. For things like symbol decorator or whatever, that definitely can result in, rather than going to something that is already pre-optimized into handwritten assembly, it can stay in JavaScript, it can stay in C++ and things like that. But generally speaking, so long as you're not doing those kinds of things, you'll almost always hit the fast path because the built-in JavaScript is designed to not use anything that the built-ins would be able to be overridden by.
I will leave it at the stop. Why don't you go?
Sorry.
Yeah.
I was just gonna add to Devin's statement. In the case of JavaScript core in particular, I know that this is probably a common concept across the engine in some sense of watch points that like, oh, these invariants that we're supposed to keep holding are no longer holding, and you're just not thereafter going to be getting this optimization, or this set of optimizations. And in JavaScript core in particular, it's a particularly terrible one that's so bad that it's just named having a bad time, just in the code. So it's just a fun fact.
Okay. Okay. Thank you so much.
Thank you, everyone.
Okay. We will go to take a rest time. Okay. Okay. I guess I can get sushi for 10 minutes. Okay, 2030, our sushi will be there. Okay, I can take 10 minutes for rest time, and so 2017 will begin the next session. Okay, take a rest.
ああ、お疲れ様です。はい、インディードで働いております。インディードで働いてるんです。同じ会社で。あ、そうなんですね。同じ会社です。古川です。よろしくお願いします。インディードって、恵比寿オフィス。あ、恵比寿に優れたんですよ。はい、あ、そうなんですね。田町なんですけど。あ、そうなんですね。ありがとう。はい、いつもお見かけしております。あ、本当ですか。ありがとうございます。了解です。あ、こちらこそよろしくお願いします。お疲れ様です。お疲れ様です。知り合いです。あ、知り合いです。はい、なんかよく映画見に。映画見に。プライベートね。はい、知り合いです。なんかネットで知り合った感じです。ネットで知り合った。ネットで知り合った。年齢的に同じぐらい。全然違う。全然違ってた。全然ってあれなんですけど。なんか僕より年下に見えるんですか。年下にいや見えます。同じくらいかな。いや僕30です。30はい。 40歳。
これ、ザクーの。
あ、ザクーの。はい。
です。
ザクーっていう会社。あ、ザクー。あ、よろしくお願いします。はい。ルカです。よろしくお願いします。以前です。はい。一回だけ。あ、そうなんです。わざわざ来てくれてありがとうございます。いえいえいえ。こんな感じでイベントだと思ってなかったんで。いや、俺も結構こんな感じでイベント思ってなかったです。この感じは、まあ、JSConf 以来じゃないですかね。JSConf ではやったことありますけど、TC さんのなんかローカルミートアップでこんな議論が活発に使うとは思わなかったです。面白いですね。面白いですね。面白いですね。これってもう多分あんまない感じのやつですね。絶対ないです。TC39 がここで開かれるときだけ。TC39 が東京のブルームバーグオフィスで開くってなってて、それがそのサウスの線路の向こう側の丸の内の側のオフィスらしいんですよ。だからもうついでにやっちゃおう。そうなんですよ。これなんかコンパス以外は告知してたんですか。このコメントにあるスッカさんっていう方がいるんですか。あれはミリオンでのコアコントリビュー。そうなんですね。自分もそうじゃないですか。だから、そうそう。すごい。森口団系を見たことある気がします。
Oh, okay. But will you present the slides or you want me to present them?
I would like to
But we'll have many people from TC39 sit up here.
Yeah, so 2 or 3 people.
Okay. TC39 panel, sit up there. Who's a panelist? I'll go up to them and say,
everybody got here. Oh, thank you. Thank you. Is that cold? Is that cold? It's okay. No, it's okay. The temperature is okay. LT はもう好きなの食べていいですよ。あ、やります？あ、いいですか？あ、いいですよ。準備しないですか？何も準備しなくて、JavaScript に関する話。あ、もちろん。LT 最初募集したんですけど、誰からも何もないから、もういいや。募集してたんですか？募集一応してたんですけど、LT 押すのはなかったですけど、LT を一応、ある人は書いて下に書いてくださいね、コメントで書いてくださいねってなったんですけど、誰も多分英語に気を張って誰も書いてないから、っていうのと、あとなんか LT がなんかあると逆になんかディスカッションをもっと一番聞きたいんじゃないかって意見も結構あるんで、だからそれで LT カットしちゃったんですよ。ただ懇親会中に LT してもらうので構わないんで、やりましょう。面白くないとみんなにうるさいな。全然大丈夫。お疲れです。8時15分、30分ぐらい。あとは途中で帰る人ここ教えてもらった方がいいです。最悪下に回収でもいいんだけど、入れるかごにあ、もういいな。じゃあもうしょうがない。最悪の最悪、一応こう回収するんだけど、努力目標。あ、そうだね。
You necessarily want you to be a panelist, or if we get 3 other people to set up?
Yeah, 2 or 3 people. It's fine.
Yeah, I will if we don't get other people.
Yeah. Oh, yes.
I don't think we need much chat. People don't want to.
Okay, 4 people now. You're also sitting with the
Yeah.
tables?
Okay. Also, okay, let's make sure there's a chair out of the camera for Kevin.
Look at
yeah, that's actually exactly right.
Okay, can we?
Let's leave a chair out of the camera.
Okay. Oh yeah, it's okay.
Can we just check where?
Okay.
Like,
Yeah.
Yeah, I think the camera is like
Camera is here.
okay.
here
And
and
here.
here.
You can see it down there, Nico, behind you. You see, this is where the camera ends.
Yeah.
Here.
Oh,
okay. And
Oh, I want to
here.
be there, but I want to be voice only. Is that
Yeah, okay.
Yeah, okay.
If you just put it over here on this side, yes. Okay. Well, I think all the chairs except for this one.
Yeah.
Yeah, it's very much like that.
Okay.
Do you maybe move the laptop there so the camera?
Yeah, the connection is the maximum length is here.
Oh, okay. Wait, I have an idea. Wait.
USB-C? Yeah, you like
And then that way they don't have their development, but just for publishing, they can expand that to the whole thing. And it's really just like a developer.
This here we could show that. And we just go along with that.
Yes, we have another idea for that.
Okay. Let's begin the next session.
Yeah.
Okay, great. Yeah.
Okay. So come to this.
Who wants to be on the panel?
Okay.
By the way, if you
Okay.
want to be off video, then you should probably stay here. Do you have
The
any
video ends like
Video is here.
video ends here. Just that that's only that video. All the other two.
Yeah, this is here is the camera.
Oh, okay.
This is the only camera here.
So the only seat that's visible is.
Yeah.
Okay, good. So, yeah.
No, wait, no.
Okay.
Let's turn
Okay.
Keep it like that.
So,
Kevin, you can
apparently
come.
you can see here.
Kevin.
Okay, good. Now I don't have to do that.
And the problem is you don't want to be in the panel, but the first time anybody answers any question, you'll be like, I want to answer.
Yeah.
Yes, that is the problem.
Yeah.
So go sit over there.
That is
somewhere.
needed.
We can make space.
Okay, next session is TC39 JSConf.jp panel discussion. Yeah, we will talk about JS weak points, next features, and so on. So first, I took a survey for all attendees, and so I asked two questions. The first one is most exciting proposals. The second question is the JavaScript weak points. The first is the most exciting key proposal. Which proposal are you most excited? So I counted the results. So here is the result. Tempo has 12 votes. So that is the most excited feature. I guess you are the champion, that's right. No.
I was somewhat involved.
Okay. No, they're champion. Yeah. Is there a champion in here? Oh, you are a champion. Wow. yeah, you got the gold medal. Okay, the next exciting proposal is pipeline operator. So, anyway, X champion. Why X?
So I was working on the pipeline operator, but there was a lot of controversy about it. There were different versions. Some people liked one version or another, and I tried to get a group of other people to make a choice. Unfortunately, we still do not have a choice, and so the pipeline operator remains at stage 2.
Yeah. Pipeline operator has some variation. That's why the F-sharp models and stuff like that.
Yeah, there was a lot of debate on GitHub about the pipeline operator. And so I tried to facilitate this debate by saying, okay, let's articulate two options, the F# version and now the hack version, which you have up here. And then we can choose between them. But unfortunately, that didn't really result in anybody becoming flexible at all. So because everybody wants exactly their version to be in the language, no version gets to be in the language.
Okay, thank you. And the third one is pattern matching. So the 7 votes. But you're a champion, or
So pattern, we have recently made a big change of pattern matching proposal because this version has some problems.
problems.
Yes.
What is the problem?
The current,
This is from the TC39
this
GitHub
is the current version, and we are drafting a new version of it. Yes, so this is the old one.
Old one.
Yeah. The problem of this proposal, current proposal is when you scan code, you cannot distinguish if an identifier is binding or not. For example, the third line, you can see destination or URL. It is not very clear that which one is the binding. So if you are very familiar with the structuring, it will be the URL, but there are just a lot of identifiers in the same line, and it's hard to tell. Last year, Julia posted an issue pointed out this problem, and we considered how things should work, and we recently approaches the new concepts to resolve this problem. For example, the new changes that the binding is not created unless you add a let or var or const before the var URL. So it will be so this becomes clear that the URL is the binding you created and the destination is not. We also have some new other features in the new version. For example, in the current version, you can only use pattern matching in the match expression, but it's not enough. We want to make things more expressive. It's hard to speak, but if you can open the GitHub, you can see what's new we have. For example, you can use the pattern matching in if statements, which makes it become like Rust have if let. It's become very like that.
So this is a beginner question, I guess. And could we put const or let in this? In this section.
Yeah. So it will be a short version. That's yes. So which means it becomes the short version. You can match the status property, meanwhile create a binding called status. And yeah, you can open the pull requests and see the second one.
This is just not shown for YouTubers. YouTube watchers.
Oh, we're not sharing the screen.
Okay. Yeah.
You can click the 3 dots.
Yes, let's show the full screen. Okay.
You can click the 3 dots right there.
Oops.
It's smaller. You can click the dots.
No, this is a better view.
This is the div view. It will become much more changes.
Oh, right. You want to click the page button.
Yeah, you can preview this edited version.
Edit version.
Here.
Okay.
And then view file.
It's hard.
Yeah, this is the new consensus we are approaching. We still have some crucial semantics that's not decided yet, but it will be the shape like this. Maybe there is, we don't have code examples.
Okay. We don't have code example.
Yeah.
But, yeah. Okay. I imagine. Okay, I can imagine. Yeah. Oh.
I want to say I'm very happy about this proposal, and I feel very positive about it. Pattern matching is still at stage 1, and the changes that Jack is talking about are developing consensus within the group of champions, within the group of people listed at the top. And later in this meeting, this week in Tokyo, across the other side of the station at Bloomberg, we will discuss the proposal, and I hope it will be viewed positively by the committee. But right now, it's at stage 1, so it's considered just an idea. Just similar to pattern matching. Not pattern matching, similar to pipeline. Or pipeline is at stage 2 now. But sort of a vacuous kind of stage 2. I mean, that's up to them.
So the syntax is fixed, and then this proposal will be stage 2 or?
Maybe. We will see. That remains to be discussed by the committee.
Not this week, though.
Yeah.
Not this week. Yeah, of course. Okay. We're gonna talk about next proposal. And I guess.
Did people have any questions about temporal?
Yeah, temporal. Does anyone have some questions about temporal? Or
Yeah.
Yeah, so temporal stage 3 proposal has been stage 3 for about a couple of years now. It's turns out that the temporal proposal is like one of the biggest, if not the biggest proposal that TC39 has ever had. It's bigger than the entire Insol API, which is the other thing that I contribute to. So it's a very big thing for the engines to implement. The engines are making progress on implementing the temporal proposal. This here is one of the APIs that we were able to design here. As part of the temporal zoned date-time data model, you have a time zone, and then you have a calendar system, which is, if it's not specified, if it's numeric year, it applies as the ISO calendar system, and then from year down through nanosecond. So one of the big things that I contributed to here was getting support for the international side of this, including non-Gregorian calendar systems like the Japanese calendar system, for example. We support Japanese eras natively in the temporal API. As well as time zones and all the other cool things that have gone into this proposal. So.
Yeah, sometimes Japanese JavaScript developers suffers from these types of issues. About data and time, and because we have time differences from other countries. So sometimes we mistake about that. So this is really helpful proposal, I guess. So there are 12 excited people, I guess. Okay. So the next is record and couple. So there are 5 votes, and this is a stage 2. So, okay.
Oh, you're a champion.
Yeah, I'm a champion of this proposal.
Wow.
So records and tuples introduces some immutable object-like values to the language, similar to, for example, tuples in Python. And this proposal is at stage 2. The champions were some months ago, 1 year ago, considering the proposal, almost done. But then while talking with implementing with like browser engineers, like we were given some feedback that implementing this proposal would be very difficult for them because, for example, it changes how quality works, or it changes many fundamental parts in browser code, and so they would need to update many highly optimized code paths. And so this proposal remains stage 2, and we are exploring to see how we can solve those concerns, maybe with a different version of the proposal.
Sounds so interesting. So, yeah, okay. So I thought, so this proposal is very interesting. So yeah, I'm most excited proposal is this. Yeah, my most excited proposal is this. And but so this proposal has some difficult features like equalities. That's right. And then so some JavaScript engine needs to implement equality properly. So that is really hard. So yeah. So I guess yeah. I just saw this syntax, and then so I think this is really easy, but it is really hard. So yeah, it is a gap between the normal JavaScript engineer and normal JavaScript engineer and TC39 people, stuff like that. But I guess so. This proposal will help the TypeScript and also botanic JavaScript features, I guess. So I think this is really interesting. Yeah. Do you have any questions? No. Okay. The third one is JSON modules. So both champions. So previously I wrote import food from food.json, assert type JSON, but this is wrong, right? So currently, so it is replaced assert to with.
Yes. So, okay, this is actually mostly about 2 different proposals. There is JSON modules, which is specifically on importing JSON files. And then there is a more general proposal that is import attributes. That's a proposal that adds that like with syntax to define some parameters. And that proposal, until maybe 6 months ago, was called import assertions, and was using the assert keyword as you mentioned. And then by talking with folks like implementing this on the web, we realized that assert was not what was needed. Like we're not asserting properties of the model, so we changed the keyword to with. And those 2 proposals are being implemented in various browsers, so hopefully they will move to like the final stage soonish, and we'll actually be able to use this as part of the language.
So this proposal is based from security issue, is that right? And so these types of security issue could be promote these types the stages, or is it not related?
Yeah, there was a very subtle security issue related to this proposal. So in Node, without Node ESM, but like you could do require foo.json, and it would load the JSON. It would choose whether it's JSON or JavaScript based on the file extension. And with the internet, with websites, the web platform does not use the file extension to decide which type of data set it is. Instead, it uses something called the MIME type. The HTTP response says the MIME type, and that's what kind of data it is. The worry was that if you import something but you don't know whether it's JSON or JavaScript, if it's JavaScript, that means you'll run the code. And if JSON, you don't run the code. So the goal was from Safari and from Mozilla that you should have to say explicitly when you mean JSON, because if you import something that says .json, but then the return MIME type is JavaScript, you'll be executing code even though you didn't want to. So that's why the explicit syntax, it runs the JSON module at a lower privilege level and avoids the code injection attack.
Okay. Okay, thank you. So these proposals are mostly technical proposals. But I would like to ask, which proposals are exciting from TC39? So who's first? Okay.
Sure. I guess, sorry, I'm Captain Gibbons, back on the GitHubs. There's a lot of proposals.
I guess sushi is coming.
Okay. The one I'm personally most excited about is iterator helpers, which is adding methods to iterators to do stuff like filtering and mapping and so on. You can do that for arrays currently, but not in a lazy way. You have to build a new array every time, which can be expensive. There's also an async version, which I think is I have been working on, which will be an opportunity to introduce concurrency, structured concurrency or semi-structured concurrency, so that you can do things in parallel in a way that hasn't really been an easy way to do before. But that one is earlier stages. So.
For me, there are three proposals or proposal groups that are very exciting. The first one is pattern matching, and I just introduced that. The second one is the module harmony. It's a group of proposals, and it's making modules become the first class things that you can operate or change or reflect with JavaScript code. For example, we have module declaration or module block proposal. If we have that proposal, which means in the future, renderer can just concat all modules in a single file, and it will become very, very fast. For other example is you can the defer imports proposal. You can defer the execution of a module until it's first used. This will improve the performance of ES module. You can do this with lazy require in CommonJS today, but you cannot do it with ES module today. And this is what we are. I'm not in the champion group, so they are slowly. The third proposal I'm excited about is the compartments proposal, which means you can create a new visualized environment and put some other code in it. By this proposal, you can emulate other environments. For example, you can emulate a web environment on Node or vice versa. If I request correctly, it also includes the module visualization, which means for a given import, for a given JavaScript code that has some import statements, you can provide your own resolution to the module, and this functionality is also interacts with the previous module harmony proposal I mentioned. So I hope they can come and you can do medicine with them, especially in bonus.
Yeah, first of all, both of these proposals, I'm super excited about them. The module declarations and expressions and compartments, those are all like part of module harmony effort that you just mentioned, where we're really trying to make sure that ESM has all the same features that CommonJS has, so you can really use like a lot of things that you can do with CommonJS right now, like custom loaders, or deferred evaluation, or synchronous imports, all those kinds of things. they're difficult to do with ESM. I mean, there's no like cross-platform standard way of doing them. And
No.
Yeah, modular harmony will solve that. So super excited about that.
We didn't say what's your most exciting proposal. Temporal. Like, those are all big proposals, I guess, right now. What I'm waiting the most is a sync, a Reddit from sync. That's a stage 2 proposal that like, it's very tiny compared to all of this. But it basically lets you transform an async iterable into an array. And like recently, I've been working with async iterables a lot. And like every time I have to polyfill this tiny helper because it's like always needed somewhere.
Okay.
The proposal I'm most excited about is type annotations.
Type
Type annotations adds type syntax to JavaScript. It makes it so that you can write most of TypeScript syntax and it will run as JavaScript. It does this just by erasing the types as if they were comments. And that matches how TypeScript works, because TypeScript just checks ahead of time, but when the program runs, the types don't do it.
So it sounds interesting, but okay. I guess there is sushi issues, I guess.
So should we take a break and come tomorrow?
大丈夫？もう一便来る。あ、わかりました。はい。Okay. So sushi will come a few minutes later, I guess. Okay. The next talk is weak points.
JavaScript has those?
JavaScript has weak points, I guess. So I asked, do you have current JavaScript weak points? And what are the weak points? So I guess. Yeah. I'm very confused about. Well, JavaScript weak points has so the one problem is JS needs to have an interoperability for legacy features. How do you feel so?
Oh, sorry. This is a strong point. This means
Okay.
you get to keep your JavaScript programs and you don't waste work when there's a version upgrade.
I wrote you a memorandum that is here.
Yeah, I think one of the strongest features of JavaScript is that like you can load a website from 20 years ago and it still works. Or a website from 15 years ago and it still works. A website from 10 years ago, from 5 years ago, from 2 years ago, and probably it still works. And this is because we take like backwards compatibility very seriously. Like recently, an example is the iterated helpers proposal that you mentioned. Chrome was shipped this in Chrome 1.17, and there was a couple of big websites that broke because of it, because they were using some polyfill that expected something about the environment which changed, and Chrome had to just unship the feature, turn it off. Nobody could use it because there was a big site that broke, and this is like. And the reason for this is because the website developers don't have control over what environment they're running, and they expect browsers to make sure that the environment stays the same. And they develop for one version of Chrome, it will work in the next version of Chrome, it will work in the next version of Chrome. So yeah, I think this is actually not a weak point, but a strong point. And yeah.
There are some facts about the design of JavaScript which have made maintaining backwards compatibility harder. One of the biggest ones is the fact that you can just replace things in the environment. You can just like add new things, like new methods to array.prototype. You can make array.prototype.flatten, to pick an example completely at random. And then depending on how you go about that, might mean that if we try to add, to pick an example completely at random, array.prototype.flatten, that might break the website. And it is good that we keep backwards compatibility, but some of the facts about how the language are designed have meant that maintaining backwards compatibility does limit us in some ways.
Okay.
Previous are both benefits, but I want to say something about to keep the compatibility. We are getting some very ugly things in the JavaScript. For example, documents.all.
There's some language, some logic is threaded through, even though it's only exposed as Ruby.
Like for those who don't know, document.all, if you put it into if statement and you turn it into Boolean, it returns false. All other objects return true.
Actually, it's an object that's equal to null, even if it's an actual object.
So document.all is a legacy DOM API that Internet Explorer had. The browser still needs to support a weird version of, and then it gets even weirder in JavaScript. So ultimately, we had to write in the JavaScript spec parts of why it was weird, because otherwise the specification would be incomplete. And we really want the specification to describe exactly how JavaScript actually works.
Okay. Sorry, I skipped some information, but yeah, I guess Sushi is coming. And okay, so the next part is some parts are scattered in various spaces. For example, Ekman Newton. This is Ekman 262 doesn't have cancellation. It's relying on DOM about controller. So how do you feel about this one?
Yeah, there was a misunderstanding between the JavaScript folks and the web folks about cancellation. Ultimately, we're able to work together well because some DOM APIs can be shared in multiple JavaScript environments through things like WinterCG. At the same time, we now have a resource disposal mechanism in JavaScript through symbol.dispose, which has significant overlap with cancellation. We haven't made a clear decision yet about how they overlap, but I hope that we come to the conclusion that disposal is just the flip side of cancellation, that it represents the same kind of action. And that is at stage 3. It's not part of JavaScript yet. Anyway, JavaScript is just the language. It's not the surrounding runtime environment. So to actually run JavaScript, you need more things. I think this is a strong point of JavaScript because it's this flexibility that's allowed JavaScript to be so widely deployed. And there's a reason why many other languages have this similar separation between the language and the runtime environment. Like C++ also works this way, but it doesn't include the whole environment.
Oh.
With that said, I agree that this particular one, a word controller being in multiple places, being in DOM rather than ECMAScript, that one in particular, it doesn't make as much sense necessarily as like all of the drawing APIs. This is kind of an unfortunate product of the fact that there's just too much stuff on the web for it to be coordinated. There's no one person who's working on all of the parts of the web. So sometimes things just happen because like the people who are working on one part of it like do the work in the part of it that they work on, and so that's why it ends up there. And
that's not what happened here. That's not worth going into.
Yeah, it is true that the people who are working on this feature were working in one way.
I described my view of the situation. There was a misunderstanding. There was not a lack of awareness. Anyway, so
it's okay. Yeah. It's hard problem, I guess. Okay. Yeah, I would like to talk about this one. Yeah. ESM and CJS separates the JS world. Okay.
Yeah, so I touched on this a little bit earlier. Within TC39, we're really trying to solve this now. There's this module harmony group where it is explicitly our goal to try to make sure that the features that you have in CommonJS are also supported in ESM. And that is to make the migration from CommonJS to ESM easier, because there's like one-to-one replacements for everything. But that's also because like there's some really useful features in CommonJS that just don't have a good ESM alternative yet. And I think it's unfortunate that ESM shipped like, 8 years ago, and
it's now 8 years later, and we still don't have a way to like defer evaluation synchronously, or we still don't have a way to have a like generic way to do custom loading, and we still don't have a way like embed one module inside of another module. That's really unfortunate, and it's like bad that it took this long. And like we need to fix this. But I think it's good that we're actively working on this. Cool.
And like regarding this, not everything is under TC39's control. Like for example, in Node.js, using a semicolon just to get Node.js is particularly difficult in some cases. But things like the require function is not something defined in the JavaScript spec. So we can try to make ESM to make it easier for like various runtimes to integrate better with ESM, but ultimately we cannot work along this, and like needs very high coordination with what the various runtimes are doing, with what various platforms are doing, and they might make different choices. Like an example is BAM supports require of ESM and Node.js doesn't. It might be a good idea to do it, it might not be a good idea, but like it's something out of the JSConf area of control.
Yeah, this is a very big pain point in the ecosystem right now. I have some friends that hate ESM because of they cannot synchronously import ESM from CommonJS, and there are also on NPM there are also many packages that does not ship the correct type definition. So if you are using TypeScript new module resolution, it's breaks, it never works. But throughout we have so many
Yeah.
splits.
Actually, we will talk about this later. So long time. Yeah. Okay. Okay. The next one is mutability is weaker than other ones.
Maybe it's not even that immutability is weaker. Immutability is like it's just everything is mutable. Which yeah, it can be really difficult. But
you can get some sort of immutability with JavaScript. Like we have phrase for objects, and we were trying to use recurrent tuples to give better ergonomics around it. Or there are libraries that allow you to make all the JavaScript word immutable, like freezing all the prototypes and doing everything. Like unfortunately, that can never be like how JavaScript works by default, because like as mentioned before, we have to make sure that JavaScript keeps working the way it was working in the past.
We have object.freeze and other. Yeah, we have object.freeze and seals, stuff like that. But lots of JavaScript developer doesn't use these types of features.
Yeah, I think starting with everything being very mutable was a pragmatic starting point for JavaScript. Just like starting without types, static types, was a pragmatic starting point. And now that the ecosystem is getting more mature, it makes sense to add more immutability features like records and tuples. The reason that records and tuples were prioritized over like immutable map or set is because JavaScript programmers just really like programming with objects and arrays. It's very convenient, and it makes sense for that to be the first priority when adding immutable data types.
I agree with all of that. I do want to also say that this is kind of selling JavaScript short, which is to say immutability in other languages depends on the language. Haskell, yes, everything is immutable. Very few other languages are actually like that. Like Python, you can redefine small integers, or C++, you can just like go poke the memory, or Java, you can use reflection to make all of your things like your private fields or your final fields non-private or final. And JavaScript is actually relatively unique in that, for example, an object that is frozen is like actually frozen. There is nothing anywhere that can change that object ever again. And this makes it possible to do some things around like immutability and have guarantees in JavaScript programs that actually you can't get in other languages. So while it's true that it is weaker in some ways, it's actually stronger in others, which gives it some interesting properties.
Actually, for me, mutability is not a bad thing, but we need to, if we be aware of it, it's okay. So I hope, personally, TypeScript is not so friendly with read-only types because you need to write read-only before every property. And I hope there is a flag for library authors so that they can make all interfaces, make all properties readable, unless they are marked as mutable. So if this is widely used, then you can use read-only types easier. For example, so many libraries doesn't change the array, but they did not mark the array as read-only, and that creates difficulties with immutable types.
In this discussion, we've been talking about two things. On one hand, you can mutate the definition of arrays. You can add extra methods to arrays or overwrite methods of arrays. On the other hand, the data structures you create during a JavaScript program, like objects and array instances, are also mutable. So I think the second thing we can improve with adding records and tuples. For the first thing about mutating the array class itself, that's a property of how JavaScript fails to distinguish the metaprogramming realm from the programming on the ordinary data realm. And I think that's something that's relatively unique of JavaScript, or similar to like how shell script or Tickle works, and not similar to how almost any other language works. For Java, you have to use Java reflection to hack into these things. Or for OCaml, sure, you'll have these references that are mutable, but if you have a function binding, it's just an immutable binding. So that's what makes things really, really weird. And I would say is a weak point of although it's a weak point now of JavaScript, it was a pragmatic starting point that allowed us a lot of flexibility to develop.
So yeah, so I guess we have two proposals to getting more immutable. So like so one proposal is they call a tuple.
Yeah.
So yeah, and then the second proposal is array. So array is an object. We leave it as more immutable, and then
So
they
we don't quite have a proposal for the second one. There was a proposal called like Frozen Realms, where you create a new environment where everything is frozen. But this is so different from what the JavaScript ecosystem uses today that I don't think we can adopt it by default, and I'm not sure if it's even practical for most large programs to adopt it.
I will upload my blog to yeah. So I understand. So yeah, my understanding is not so perfect, and so I would like to so research and collect all of proposals to discuss about that.
But the mutability is only one case, one of many places where JavaScript confuses, normal data structure manipulation with metaprogramming. Another one is accessing prototypes. You have this .prototype property, which you can read and write like other properties. And this causes a security issue, which we're investigating now in JavaScript. If you have a naive, JSON clone function, it can cause security problems if that JSON came from user code and has a property called prototype. It can let you overwrite existing prototypes, which can really cause code injection attacks. So the real weak point is confusing the metaprogramming domain with the data domain.
So interesting. Okay, next is JS developers could not handle undefined property access and find these faults at production. So this is just okay.
Yeah, I think the tooling around this is much better. TypeScript is a real solution to this. And as we see in like surveys from, for example, Stack Overflow, like TypeScript is gaining a lot of adoption. I think it's safe to say that the majority of new projects nowadays do not use JavaScript as is, but they use TypeScript, and they don't just use TypeScript like as is, but they use very strict versions of TypeScript that do undefined checks and null checks. And while this will always be a problem, I think like it's getting a lot better because JavaScript programs in general are getting more structurally typed. They're getting types don't shift around as much. It's because of TypeScript. So hopefully this will improve.
How does optional chaining relate to this?
And yeah, JavaScript is also has added features recently, like optional chaining, so the question mark dots, that help with this, where you have optional property access, where if the value is undefined, it will fall back to undefined rather than to undefined.
Okay. Crossing things.
Can you translate the question?
Yeah.
I really want to know what the Japanese says.
Crossing things is, yeah, so
like what is the translation of this?
yeah. So yeah, if we put not a number, so JavaScript API understands that is 0, or so if JavaScript API requires string, but we put number, and then that is converted to string automatically. So that is crossing thing. So yeah, it is not. Yeah, it is unpredictable. So I guess so. This weak point exists.
Okay, so I'm excited to talk about this one. One of the things I have been pushing for in the last meeting, and hopefully this meeting, if we have time for it, is to stop doing this for new APIs. So I want to be clear that I am not proposing to change the behavior of anything existing. As we've talked about, JavaScript is very careful about maintaining backwards compatibility, which means that even for very simple, stupid things, we can't change them ever. But I would like us to stop doing this in the future, to have, if we are adding a new API that takes a number, that takes an integer, for example, I would like us to design that API in the future so that it throws if you give it something that is not a number, or nan, which is kind of a number, or like 1.5, which is a number, but it's not an integer. So if it's expecting an integer, it should throw,
So
or the string one.
in that case, so API emit errors or throws errors.
Yeah.
That's why. I got it.
Yes.
Yeah, that is better.
I agree.
But wouldn't that break the spirit of JavaScript?
No.
Okay.
It is the main complication with this question is that it will mean that all APIs designed after a certain time will behave fundamentally differently from all APIs added before that time, because all existing APIs have this coercing behavior. And it is unfortunate to have things in the language that work in very different ways. In this particular case, I think that the coercing behavior is so confusing that it is better to have new things behave better, even though that means they will be different from old things. But it could be argued that it would be better to just keep doing things the way we're doing. So far, at the last meeting, we actually did the agreement that nan in particular should not be treated like 0 in new APIs. So that one in particular, in any new API, and by new I mean not just things that are like, some of the things that you haven't started using yet are not new, they're done from our perspective, even though they're maybe not something you can use yet, but like going forward, new proposals in iterator helpers, for example, you will not be able to pass random strings and have those end up being 0. So some progress. And then temporal. Yeah.
Wow. Okay, the last big point is prototype pollution.
Can you elaborate on what the issue people are talking about?
So some people said so this is just prototype pollution, and I don't understand so how to deal with this one. But I guess if a prototype pollution exists, so your all JavaScript object is invalid and is polluted by these types of things. So so I guess so he would like to ask, so how to handle these types of program from TC39 members? Do you have any solutions or?
Yeah, I'm familiar with something called SES, which means Secure JavaScript. That proposal includes many things, but the thing that's relevant to the prototype pollution is called, they have two solutions. The first one is called lockdown.
Lockdown.
Yeah. which means the built-in built-in prototypes are frozen, so you will not be able to add new things on a result prototype or replace a regular prototype to something evil to steal data. And it also provides a function called harden. It's also in the global objects, which you can maybe I thought it can recursively freeze objects. So if you harden a class you made or an object you own and you pass it to other code, they will not be able to modify it. But we have many legacy programs, so this might not work. And another solution is what we call the compartment proposal.
Compartment proposal.
You can remove the compartment and replace it with wrong.
Wrong.
Yeah.
Wrong. Wrong.
REALM.
Realm.
Wrong. In this proposal, you are being able to create a new environment. So if some library is modifying the prototype, you can run it in a new ROM. So the main ROM and new ROM are separated. The prototype rooted in the new ROM will not affect code that's run in the main ROM. And that's another solution to this problem.
Oh, wow. Okay.
For the status of those two proposals, lockdown with SES is something that you can use today. It's just a JavaScript library and it already works. Realms is a proposal currently at stage 3, but in this Shadow Realms. Shadow Realms accomplished what you mentioned. Shadow Realms are at stage 3. They accomplished this isolation in a prototype chain which is not connected to the outside one. However, there is some work needed to integrate Shadow Realms into the web platform. The goal is to make it so that a Shadow Realm has a full environment of just the built-ins, and some built-ins, like a port controller, are not standardized in JavaScript. So the idea is for Shadow Realms to have a complete set of built-ins that don't do any input or output, but not drawing a distinction between a port controller and array. However, there's a lot of details to work out, and these have not been completed yet. So we're planning on at least it's proposed in this meeting, to retract Shadow Realms from stage 3 to stage 2. Hopefully, following this, there will be active work to resuscitate that proposal and make it available. But despite that, if you're in Node, you can use the VM module to create a new context and achieve some of the same things, but it's easier to get wrong.
Yeah.
And just to comment on this, do not use the VM module for security-related applications. It's not designed.
Yes.
Very important.
Webpack used this, and I found a security bug last year.
Don't do this. It's the first thing that it says in the docs. Do not do this. Yeah. Sorry.
Doesn't solve security problem. Is that right?
Well, some people will tell you otherwise.
Well, they are wrong.
They could come to this panel if they felt like it. Okay, I think, is there another slide?
Yeah, we have another slide, but I think we would be better to eat sushi.
Okay.
Oh, is that right?
Yeah. Let's see if anybody has any.
Yeah.
Does anybody here have questions?
Oh, okay. So, there are any? So, does anybody has questions?
And if you prefer to ask questions to us later, that's cool.
What's the next
We'll be
one?
walking around.
Next one is just sushi. No, no. Oh, okay.
So it's I was wondering if there were a conversation about a kind of JavaScript 2.0 that is like a subset of JavaScript, something maybe like the good parts, and maybe with some different APIs like was mentioned before with the enforced types, and maybe could support like a TypeScript that has like a sound type system, and maybe with a word like in other was both, maybe something can be corrected.
Yeah, so a couple of years ago, Google tried this. It's called Dart. It didn't work. And it did work in some circumstances, but it didn't work on the web. And I think probably the reason is that there's too much existing JavaScript, JavaScript 1 out there. And having a new language which has the same name and tries to be, to some extent, compatible with the existing language is really, really difficult. Like, you see this Python 2 and Python 3, fundamentally the same language. There's some changes, obviously, between the two, but the migration is like years, right? If not longer. And like, we're finally done with Python 3 now. Like, it's pretty much, well, okay. The V8 build system migrated to Python 3. This took like, I don't know, many, many years. Like, after Python 2 was deprecated, people still use Python 2, and they still do now. And we will never stop being able to use Python 1 or JavaScript 1 if we were to do a JavaScript 2. So it's probably not feasible. Like, incremental addition is easy.
V8 will also try another new directive called use strong, and it's also failed.
Yeah, strong script, right? Strong mode.
Yeah.
It's also JavaScript, but with a new directive.
Yeah.
Yeah, so
use strong.
There also isn't really a lot of alignment between what people say when they say they want a new, stronger version of JavaScript. Many people have many different things that they would want. And I think just incremental compatible evolution like we've been doing is probably the safer path and some radical change. Also, a third thing was ECMAScript 4. That was also being developed around the same time as Dart, and it had a bunch of radical changes, and ultimately the decision was to make more incremental changes instead.
Also, sound type systems are really hard. Sound interesting type systems are even harder. TypeScript not being sound is inelegant, but very useful. It would be nice if we could have something that is both useful and sound, but that's just like really hard.
If you want that, you can use Rust, but it's totally different paradigm. Rust isn't sound.
It has a sound subset.
Okay, it's not complete, you're
Okay,
saying.
it's sound for 99% of all applications.
Oh, you mean with the unsafe thing, yeah.
Python 2 and Python 3 code is migration program, that's right. But I guess the CJS and ESM also have these types of program.
Right, so do we want to make a third thing?
Yeah, we would like to talk about this. Is that okay? Yeah. Okay. So ESM status and TypeScript config module props have many options like ES2022, Node.next, Bangla, etc. This prop nightmare is introduced by Node.js, CJS, and ESM options. So I'm Node.js guy. And Node.js has CJS as ESM internal feature. Historically, CJS is needed in Node.js. ESM was declared in 2015. Node.js core committer thought two specs would cause migration issues, I guess. So Node.js implemented CJS ESM interops using the file system extension and the package JSON type field. So this is the beginning of the nightmare, I guess. The spec difference. So ESM and CJS are totally different. So ESM async load, CJS sync load. ESM static, CJS dynamic. ESM pass by difference, CJS pass by value. So my opinion is TypeScript developers feel Node.js brings ESM CJS nightmare. So Node.js developer feel if CJS into ESM install has never been implemented, migration nightmare will start. So I guess TC39 people think module system is required, and it would be better to be browser friendly. So CJS is not ideal option. Is that right? So I would like to ask this type of question, and so positive.
I think Luca.
Okay.
Yeah, I think a lot of this is trade-offs. Like Node.js could have made different choices that would have made some parts of CJS ESM interop easier. They didn't. They chose for other things which maybe were cleaner or maybe were simpler to implement at the time. And maybe hindsight is 80-20, right? Like looking at it from the future is always easy to say, oh, this was wrong. But maybe at the time this looked like the right decision. And I think we are moving in the right direction now. Like TypeScript has done a lot of work in the last couple of months, in the last couple of releases on better resolution modes for new like Node's ESM resolution and aligning that to how TypeScript resolves things. Dino is ESM only, for example, and still allows you to import CJS modules via npm colon specifiers, which sort of like shields you away from all of the badness of CJS. Bun has been trying to do things where you can like synchronously import ESM modules using require, which is really interesting. And I think over the next couple of years, months, we'll see more like boundary pushing in this direction. And at some point, we'll be done with the migration, hopefully, but maybe not. But at some point, people will sort of have figured out what works and what doesn't work. And I think right now we're just still in the stage of not quite knowing what works and what doesn't work. And I hope we'll get there soon. And I think, personally, I think it was the right choice to have a module system that is native to JavaScript and like works well in the browser, is asynchronous. I think this was a good decision to make. But yeah, there's pain that it causes, and like we need to work within TC39 to make this better. For example, like use it like inside of the module harmony efforts that I mentioned earlier.
Does they have any other opinion?
Yeah, I guess this slide is most about how it's implemented in Node.js, not just really tools. But like, as we mentioned before, one problem we are aware of is that CJS still offers some features that ESM doesn't have. And this is preventing different projects migrating from one system to the other. This is helping the ecosystem back. As an example, Annotate, Babel, like JavaScript and Spider. And we are using CommonJS in a way to optimize our startup time. We just cannot, do the same with ESM. And we are now decided to still migrate ESM even if it gives us worse performance. But like within TC39, we're also trying to solve these problems to actually help making the migration from one to the other smoother.
Yeah, I would also mention ESM isn't even good for browsers right now. Used in practice, if you have a medium-sized program, you have to convert it to CJS or AMD in order to ship it in the browser if it contains hundreds of files, because you have to bundle them together. You could make it ESM on the outside, but on the inside will still be CJS or AMD. This is, maybe nobody cares, but this is why I'm very excited about multiple declarations, because they allow this bundling to take place in ESM as opposed to going back to these other kinds of module systems.
Specifically on this, like there are some bundlers like Rollup and ESBuild which do natively support bundling ESM at the cost of not being able to bundle top-level await properly.
No, but they bundling ESM in which sense?
Like combine multiple ES modules into a single ES module. ESBuild.
I'm a Node.js member here, so I would like to add a comment on this particular issue, is that Node.js strives to keep compatibility between the web platforms on the ESM module, specifically since it is available across different web platforms and Node.js and like environments like Dino and Bun. So it is important to avoid the incompatibility between those platforms. So that's why it's a big point for Node.js to make decisions on the ESM and the CJS compatibility. And still, Node.js colleagues of mine are still working hard to improve the CJS and ESM interoperability. For example, you can now import COM.js modules in ESM with simple import. Like you can import CJS in ESM, like you import ESM in ESM. So my colleagues are working hard in the interoperability, and we have a very hard guideline on keeping the compatibility between those platforms.
So import from ESM file, this is okay. But the import from ESM from CJS file, that is really that is not okay, I guess. And so this is really important. And yeah, so I'm thinking, so library developers like Sendo Sohos, so he would like to proceed, so from CJS to ESM. So his libraries supported ESM only. But in that case, so everybody needs to upgrade our modules and applications. Yeah, but I think this is not so good solution. And yeah, so I think more powerful vendors and developers like Google or Basel, stuff like that. And then so yeah, Basel creating Next.js, this types of powerful application. So I think so they would be better to so these types of developers would be better to have more good solutions about this. Yes. So if Next.js will change so from CJS to ESM natively, so every modules would be better to follow these types of solutions. So that is needed, I think. So how do you feel about that?
Yeah, like as library maintainer, migrating from COM.js to ESM can be scary, because it means that whoever using the library will have to use ESM to like import your library. But like or BSC, like we have a tool for this. Like all the NPM ecosystem is based on some variant. Like we can incorporate changes. We can push up like publish a version that's not compatible with the previous version and like just switch to a different model system. And like more big libraries doing that will help pushing even more libraries doing that. And like if you're writing an application, just use ESM because you can import both of that. If you're maintaining a library, you can be part of this progress and help other people migrate and push other people to migrate. And like
The more people work on this, the faster it gets, and like you just have other libraries that migrate and like will be done soon, hopefully. Like library maintainers step up.
I think this is very much like one of those Python 2 versus Python 3 problems, where it will take a really long time and will get done eventually, but it like will require that at some point Node says we're dropping CommonJS support in 3 years, so everybody go hurry up. Like maybe that doesn't happen for another 10 years, who knows? But we'll see.
Okay. Okay, we are reaching 9:30. Okay. I would be better to quit this moment, and yeah. So I think my opinion. So this is nobody's fault. Future prediction is really hard, right? So we would like to move forward fast. So that is a problem. This is the point, I think. Yeah. Okay. So my conclusion is this, and so I'm pretty appreciate for this event, and so I would like to communicate each other, and I would like to serve sushi in that. So 寿司って用意できてます。出ます。はい。じゃあもうここで切るんで寿司食べましょう。So let's start sushi time. So yeah, sorry for long time meeting. Yeah, thank you so much. So please. Okay, let's start. Thank you so much. Yeah. Thank you so much. Thank you so much. Thank you so much. Thank you. Thank you so much.
It was very great questions you had.
Yeah. Thank you so much. Yeah.
This excellent setup, excellent questions to guide.
Thank you so much.
and also, I like this section on ESM because I think it's something that you are bringing like the community view, which is the reality of using JavaScript. That we don't talk about that so much in committee because it's very easy to say that that is a node specific problem. Like for example, Dino does not have this problem.
Yeah.
So it's the runtime choice also. However, for JavaScript developers, they don't care who is the name. They just want a solution.
Yeah.
And I think overall it will take 10 years. So Python 2, Python 3 is 10 years. But most working